Let's say you have a perfectly indexed table. Queries are fast, everything looks good, but suddenly performance drops. Sessions are waiting, CPU is fine, but response is very slow. What is happening here? This is a classic case of hot block contention, especially when using sequence based indexes. All inserts go to the same index block, multiple sessions compete, so weights increase. Now you might think, should I drop the index or redesign the table? No need. Oracle gives a very smart solution for this problem. It is called reverse key index. Instead of inserting sequentially, Oracle reverses the key values. This spreads inserts across multiple blocks. No more hot block contention. In this video, I will show you what is reverse key index, when to use it, real example with execution behavior. So you can fix this issue like a pro.
Have you heard this reverse key index? In normal index, what happens in B-tree index? So root will be there, branches will be there, and leaf nodes are having a row ID with value. Have you heard the term called hotspots? What is with respect to technology or with respect to traffic, whatever it may be, what is hotspot? Any guess? See, suppose if you take employee number, okay, and we created a B-tree index. Maybe here you have 100, okay. Employees whose employee numbers are less than 100 will go like this. Again, this will have branches, all leaves like this, okay. See, in the beginning of the company beginning, definitely it will start with employee number 1, right? Employee number 1, 2, 3 like that. So in this tree, your left tree is having more values than right side tree, because once it reaches 101, then you will have values in right side tree. As of now, only left side there are more values. Am I correct or not? Because 1, 2, 3, 40, 50, all will be we'll be storing in Oracle will be storing in the left side of the left subtree, not the right subtree. Okay. So when you are querying, what happens? Most of your queries will be hitting these blocks, and here nobody is accessing because there is no data. Because it's an order tree, right? It's an order tree. 1, 2, 3, 4. Orderingly, it will store it. Its nature of the data is ordering, but because of this, all processes are trying to access the same blocks. So at a time only, maybe some 10 process can access or 5 process can access. But if concurrent access, like 1000 people are using online program, so other users have to wait, right? So a lot of data concentrated on little dense portion we call as hotspots. Okay. So can we do something from backend wise? Like, definitely we cannot ask them to, okay, start from 101, 201, 301. We cannot say that to the application because it's not correct. So what we can do is, Oracle is giving us a feature called reverse key index. Okay. In this case, what it does is, suppose data is 21, okay, or 12, it will store as 21. If you have 81, it will store as 80. It reverses the data. So in that case, you will not have data sequentially. It will become, suppose if you have 91, it will be stored as 19. Only for index purpose, but not, it won't change the exact data. Okay, suppose if you have data like 4771, all employee numbers are starting like this, okay. 4772, 4773 like this, okay. Actually, when they reverse, what happens? 1774, 2774, 3774. So definitely this will go to one branch, this will go to another branch, like that, right? Definitely, in this case, all these three values will be in the same data block. But in once the data is reversed, it will go to different data blocks, right? In that way, that hotspots we can try to reduce, right? Okay, so everything is done internally. We will not, what we do is only we create index with reverse option, keyword it is. Okay, so create index name on table T, whatever columns, reverse. Once you say reverse means that's all we do it. We won't change the data. But the way index the entries are stored and retrieved are different in a way to reduce the hotspots. Technical term is buffer busy wait. Buffer busy wait means it is requesting for some buffer, but since it is logged by some other internal process, the other process is waiting for that buffer. Okay, buffer busy wait means it is asking for a buffer, but it is logged by some other process, so it is waiting internally, which is not visible to us. Okay, so most of the time for all sequence numbers while designing also we create reverse key index. This is called reverse key index. See, first we'll try to go for normal index only. Whenever you are facing a problem, that time we'll change it to reverse. Okay, and also sometimes people who already know such potential problems may be there in future, beginning itself they create reverse key. Okay, so either you do it proactively or reactively, it is in project and technical person hand. Okay, all other operations are same. You can create, you can drop, you can rebuild, all are same. Okay, sequential data loads causes the index to encounter IO bottlenecks. That same thing, IO bottlenecks means it is trying to access these IO bottlenecks will be there just because in one part of the disk all end users data is heavily concentrated and processes are competing for that particular part of the disk. Okay, this problem can be eliminated by storing index table spaces on disk architectures that permit the files to be physically striped. See, there are so many other things also we do. Index table space, what we do is, this is sysadmin will do, striping. One data file in one disk, second data file in another disk. But what you will do in the same data file, all the data is stored. So that time striping will not help us, right? Physical striping will not help, right? So that time we reverse what exactly does is reverse key index compared to a standard index, reverses the bytes of each column indexed except row ID. Row ID will not be changed because row ID is address, right? While keeping the column order. By reversing the keys of index, the insertions become distributed across all leaf keys in the index so that they are not densely stored in one place. Okay, so whenever we see expensive, like there are so many wait events, okay, which we can see later on in one of the data dictionary. If you select start from sysstats or session stats, you can see by name buffer busy waits. Okay, there are so many wait events. See, for one SQL, why it is taking more time means maybe it might be waiting for some resource, maybe to bring it from disk or whatever reason it may be. So that if this is the event, we can expect there are hotspots. And we also analyze the nature of the data, right, in the table column. And also if we see this, definitely we can suspect that the hotspot is happening, so we can recreate the index using reverse option, because it depends nature of the data, nature of querying, so many things. Okay, so this is one type of, it hardly takes any time for us, for a DBA to drop this index and create it reverse, right? So always, not only the SQL, even we have to have a high level bird's overview of nature of data also. So many things we are learning, but based on the type of problem, we apply one type of fix. Okay, that's what I'm telling. First, we should know what is scope to tune it. We should be ready with statistics.
Explore our Oracle Performance Tuning and Dimensional Data Modeling with eRWIN tool courses. Upskill with our video courses at your own pace and time. Courses are created with real-world scenarios and ready to work immediately by industry experts.